How do we find the domain of radical functions? Well, let's always recall that the square root, we can always find the square root of non-negative numbers in the real world. Later on, we'll find a way to find the square root of negative numbers. But for now, in the real world, we cannot find the square root of a negative number. For example, the square root of 16 equals to 4. Why? Because 4 squared equals 16. Why do we square? If you recall, every time we talk about the radicals, we have the index. In this case, the index is 2, which we don't write. That's the default. So we are looking for a number that when I multiply by itself, the index number of times will give me the radicand. In this case, when I take the number, when I multiply by itself 2 times, will give me the radicand 16. Of course, we know that if I multiply negative times negative, the answer will be positive. So there is no way I can go back to a negative number if I multiply 2 negatives. Of course, if I multiply 2 positives, the answer is also positive. We can extrapolate if I try to find the fourth root of a number, this number cannot be negative. Why? Because if I multiply negative 4 times, let me just use, if I take a negative 4 times, the answer will be positive. So I cannot go back to a negative number. If I'm looking for the sixth root, that means I'm looking for one number that multiplied by itself 6 times, that will give me the radicand. So if I take 6 negative, I go back to positive. Of course, 6 positive, go back to positive. So we cannot find a number that will take me to a negative number if I multiply by itself even number of times. So for now, let's go back here. So we're doing the square root, which we don't write the 2, obviously, that's your default. So this is why we cannot find the square root of negative numbers in the real world. The graph looks like this, very simple. If I have x, the square root of x, when x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is also 1. If x is 4, the square root of 4 is 2. 9, the square root would be 9, the square root would be 3, 4, 16. So the graph continues like that. And this is why the square root of x looks like that. Notice if I attempt to do the square root of negative 1, there is none. This is why the domain of the square root function is x greater than or equal to 0. Like that. And that means from 0 to infinity. Now, if I need to look for the domain of the function f of x equals x minus 4, what number makes this guy non-negative? Can I choose 3? No. Can I choose 4? Yeah, because 4 minus 4 is 0. Can I use 5? Yes, 5 minus 4 is 1. So as long as I'm from the 4 to the right, I'm safe. If I go 4 to the left, I'm in big problems. So how do we solve this? Very straightforward. We know that the radicand must be greater than or equal to 0. So everything boils down in solving that, the following inequality. X minus 4 greater than or equal to 0, therefore x must be greater than or equal to 4. So that's the domain of this function. In interval notation, bracket 4, comma, infinity. If they ask us find the domain of the function f of x equals 7x minus 5, what do we do? Well, I know that since this is the square, it's 2, even, the radicand must be greater than or equal to 0. So everything it boils down in solving the inequality 7x minus 5 greater than or equal to 0. We may add 5 and we may divide by 7. So x greater than or equal to 5 over 7. So that's my domain. As long as I'm to the right of 7/5, I'm safe. Anything to the left, I'm in big trouble. What if the function is as follows? What if my function is f of x equals the square root of negative 3x plus 9. Then same old, my radical must be greater than or equal to 0. Thus, negative 3x plus 9 must be greater than or equal to 0. We subtract 9, negative 3x greater than or equal to negative 9. We must divide by negative 3. But every time we divide by a negative number, we switch the direction of the inequality. So now, as long as I'm from the 3 to the left, I'm safe. So the domain will be from negative infinity to 3 bracket. Okay. So in this case, we have to be from 3 to the left. Since the negative will force me to have a negative number, so this guy becomes positive. That will be the domain. So that's all we need to do. Remember, we don't write the 2, I'm going to do it on purpose. I'm doing for an even root. If I have the following, first of all, let's just talk very quickly about the cube root, so cubic root. F of x equals the cube root of x. Here, I don't have any issues because if the x can be positive or negative. So the domain is all real numbers. Oops, sorry. Domain is all real numbers, negative infinity to infinity. In fact, the graph of the cube function looks like this. So it's defined for every single number of x, which is fine. So if they ask us to find the domain which of the following, f of x equals the cube root of 2x plus 7, the domain will be all real numbers. I don't have to do anything. The domain I know is going to be all real numbers. As long as it's the cube root, even the 5th, the 7th root, the 9th root, etc. Odd root, we are safe. The domain is always of real numbers. Even roots, that's when we have an issue, because the argument, the radicand, cannot be negative in the real world. I hope this helps.